Am I clearly audible to you? May I start? So, metallurgy chapter we are going to discuss. So, here, what do you mean by metallurgy? Metal. If I split this word, it means metal and energy means extraction. So, we are going to extract a metal from its ore. We are going to do what? We are going to extract it. We are going to extract the metal from its ore. So, that is called as your metallurgy. So, we will discuss it how it happens. So firstly here introduction has been matters and knowledge of people. There are total 180 different elements known as these elements are widely distributed in our industry state and some are in the combined compounds. Some are metals and some are non-metals. So all the metallic elements except mercury, this is the important exception, are solid where your mercury is liquid at room temperature. It is a matter, but it is a liquid at room temperature. And 11 non-metals are gases. One is a liquid, that is the bromine. So liquid is a liquid, liquid bromine. So bromine is a non-metal and it is liquid at room temperature. Right. So this is also exception. So now we will move towards how metallurgy is going to how we are going to extract the metals. Firstly here some basic things are given, like here alkali metals. Alkali metals are first group element. Great. First group element in the S block in the periodic table. So they are alkali metals are lithium, sodium, potassium, rubidium, cesium and francium. Yeah, these are actually what is special about the alkali metals. Our alkali metals have only one electron in the outermost orbit or outermost shell. They have only one electron in the outermost shell, right? So your alkali metal, important one, this is their chemical property, that alkali metals react with water to form the hydroxides. When they react with water, they are going to form what? They are going to form hydroxide. For example, this is my alkali metal. I denote alkali metal with M. So H2O. So here it will form MOH, that is metal hydroxide. Metal hydroxide, right? A question can come that which gas is evolved here. So hydrogen gas, H2 gas is evolved here, H2 gas is released here. Important thing, hydrogen is placed in this group, in which group? In group number 1. Hydrogen is placed. Why? Because it has one electron in the valence shell, but it is not an alkali metal. So alkali, what are the general properties of alkali metals? They are soft in nature. They are soft actually. So what are the different features or characters of the alkali metals? Firstly, all the alkali metals are very reactive and does not occur in the free state. They are very reactive. They occur in the combined form. They do not occur in the free state. They are soft, as I told you. They can be cut with a knife, for example sodium, right? So they have low melting and boiling point. Important, they have low melt. Am I clearly audible? Okay. They have low melting and boiling point. They are soft. Bonding, all alkali metal salts except some salts of lithium are ionic in nature. So I am saying that except some salts of lithium, that means salts of lithium, they are not ionic, they are covalent in nature. They are covalent in nature, whereas all alkali metal salts, they are ionic in nature. So lithium is the exception. First element, first element in its respective group, it is the exception here. Clear? So let's move further. What is the action? What about the action of water? What about the action of water? Our, what is special about the alkali metals? See, they react with oxygen, they react with oxygen and vapors in the air. They react with oxygen and water vapors which are present in the air. So important thing that reactivity of these metals, reactivity of our alkali metals, these increases down the route. So can you tell me which one will be the most reactive? If I am giving you example, lithium, sodium, potassium, rubidium, cesium, which one will be most reactive out of these five? Yeah, your reactivity of these metals, they will increase, that will increase down the group, that will increase down the group. Next one is my action of water. They react violently with water and produce hydrogen. They react violently with water and produce hydrogen. I have a alkali metal, it react with water. I told you that any alkali metal that will react with water, and it is going to form my metal hydroxide. It is going to form my what? Metal hydroxide. Tell me, Arjun, which gas is evolved here? Hydrogen. Great. Next one we are going to discuss, what about the action of acids? They react. Our alkali metals, they react violently with dilute HCl and dilute H2SO4. For example, if I'm taking here, let's say I have alkali metal M. Okay. And here I am reacting it with dilute HCl. I am reacting it with my dilute HCl. At that case, see, firstly, my metal chloride will be formed. My metal chloride will be formed. For example, here let's say my alkali metal is sodium. So at that case, my NeCl will be formed, right? And apart from this, hydrogen gas is released here. Important thing, you know, Arjun, what is ionization energy? You know what is ionization energy? It is the energy required to remove an electron from the, it is the energy required to remove an electron from the, from the, hmm, outermost shell. Yeah. So your alkali metals, they have low ionization energy. So means, if I'm saying they have low ionization energy, so it simply means that here electron can be easily removed, right? They have one electron in the outermost shell, and they can easily remove that particular electron. And at that case, which ion will be formed? Our unipositive ions are formed. Our unipositive ions are formed. So you know, electron is having which charge? Positive or negatively charged? Electron negatively charged. So if your metal, if your alkali metal is losing electron, let's say my alkali metal is losing electron, so at that case it will form what? As it is losing one electron, so it will form unipositive, unipositive ion, right? Our unipositive ion is formed, right? So for example, I can give you a simple example. My sodium is there, right? If my sodium is losing one electron, tell me what will be formed here? Na positive. So our alkali metals, they are strong reducing agents, that means. So what is special about the alkali metals? Number one, they have low ionization energy, they are strong reducing agent, they are generally soft. Next one, when freshly cut, they show typical silvery white metallic luster, but soon they turn dull because of their reaction with air. So when you cut it freshly, so at that case they show silvery white metallic luster, shining, but soon they will turn dull because of their reaction with air, as they are very reactive. So very important special point about alkali metals, that all the alkali metals, they impart color to the flame. All the alkali metals, they impart color to the flame, right? So for example, this is important one, lithium. Lithium impart crimson red color to the flame. Which color? Crimson red colored flame. Your sodium impart golden yellow color to the flame. Golden yellow color, this is also important. Next, potassium, pale violet color. It imparts pale violet color to the flame. Lithium imparts crimson red, sodium golden yellow, and my potassium pale violet. Now, I told you that alkali metals they form the salts. So alkali metals are obtained. For example, NaCl is a salt, right? So alkali metals are obtained by the electrolysis of their molten salt. Molten means when you melt anything, right? So it is the molten state. So alkali metals are obtained by electrolysis of their molten salt. In the electrolysis, we pass the electric current through the solution. Arjun, is this clear? Maybe proceed. Next, we will discuss after 5 minutes alkali metals, alkaline earth metals. Okay, let's firstly discuss alkaline earth metals. So, alkaline earth metals include beryllium, magnesium, calcium, strontium, barium, and radium. These are known as alkaline earth metals because their oxides occur in the earth crust and their hydroxides are alkalis. Their oxides occur in the earth crust and their hydroxides are alkalis. So now we will see there some of the reaction. Actually, they are group number 2 elements. They have 2 electrons in the outer motion. What are their general characters? First, occurrence. They are reactive metals, hence do not occur in the free state in nature. Reactive. Next, they are grayish white in color, harder than alkali metals. Important. They are harder than alkali metals. All the alkali metal salts except beryllium are ionic. Same thing in case of alkali metals. Same thing in case of alkali metals. Even your first one, that form the covalent lithium, right? Here also first one is exceptional, right? It also form the covalent compounds, whereas all other alkali metal salts they form the which type of compounds? Ionic. If I see the reactivity, ionic compounds, all other alkali metals, whereas your alkaline earth metals, whereas your beryllium that form the covalent compounds. This is exception. Next, action with air. If I compare the reactivity of alkali as well as alkaline earth metals, so important that our alkaline earth metals they are less reactive as compared to the alkali metals. They are less reactive. Okay, their reactivity increases on moving down the group. On moving down the group, reactivity goes on increasing. Same as that case in case of alkali metals. Next, action of water. They react with water to form the same thing. Hydrogen gas is produced. Same in that case of alkali metals. So, for example, my beryllium is the alkaline earth metal. Let's say. So plus H2O, it will form what? It will form your beryllium hydroxide, BeOH twice, right? Beryllium hydroxide plus hydrogen gases evolved here. Clear? Next one is my action with acids. So they react with dilute HCl or dilute H2SO4 to produce hydrogen gas. So for example, my alkali metal, let's say, is my beryllium. So what will be formed here? Let's see, beryllium plus HCl, that will form my BeCl2. It will form my BeCl2. At the same time, my H2 gases evolved here, right? And if I have the beryllium, it will react with H2SO4. It will react with H2SO4. So at that case, what will be formed? Beryllium sulfate, that is BeSO4. BeSO4. So hydrogen gas evolved here. Important one. Our important one, same thing we discussed in case of alkali metals also, that they have low ionization energy, but important thing that is higher than the alkali metals. So important one, that if anyone asks you that out of alkali metals and alkaline earth metals, which one will have the high ionization energy, tell me. Yes, to form the here, as they are losing two electrons, they are having two electrons in their valence shell. So that means a di-positive ion is formed, not uni-positive. So, for example, my alkali metal is the beryllium, right? If it is losing two electrons, at that case it will form my beryllium 2 positive. So they are also strong reducing agents. Melting and boiling point are low. But same as that, in case of the alkali metals, melting and boiling point are low, but these are higher than the alkali metals, if I compare the two. So it is higher as compared to that of alkali metals. Important, very very important question. Except beryllium and magnesium, except beryllium and magnesium, all other alkaline earth metals impart color to the flame. Very very important question. Question can be asked. These first two, beryllium, because their electrons, they are not excited actually, right, to the higher energy level. So that's why my first two, beryllium and magnesium, MCQ question, they do not impart color to the flame. So now, as I'm saying that others, they impart the color to the flame. So what about their colors? Like calcium impart brick red color to the flame, brick red color. Your strontium, that impart crimson color to the flame. Right, barium, apple green color, important question, apple green color to the flame, my barium. Right, radium, crimson color flame. So important one here is the calcium, asked in the exams, brick red color flame. Barium, that is also important, green color flame apple green color flame, right? So a strontium, and you can remember by sr saraswati. So as for strontium, r for radium, these both crimson color to the flame. But if they ask you that which of the following alkaline earth metals, they do not impart galactic color to the flame, so my answer will be beryllium and magnesium. Now, one similarity between the alkali and alkaline earth metals, that they are obtained by electrolysis of their molten salts. This is the similarity. This is similarity between the two. Now, we completed up to the alkaline earth metals. Hope you understood these points. So now I am going to discuss here about the transition metals. Now my topic of discussion is transition metals. So as I told you that my group number one elements, they are alkali metals, group number 2 alkaline earth metals. So group number 3 to group number 12, these are my transition metals. Their two outermost shells are incomplete. Very, very important. Their two outermost shells are incomplete. Now we will discuss here some examples. Like iron is my transition. Iron is my transition metal. My zinc, copper, mercury. These all are my transition metals, right? Now, what are the characters of my transition metals? Listen these carefully. These are important points to remember. Maintain a proper concentration. Listen these carefully. So what are the characters of my transition metals? First one, all these elements are metals with high melting and boiling point. All these elements, all the transition elements, they are metals, right? First thing, they have, if anyone asks you that transition metals, they have the high melting point or low, so they have high melting and boiling points. First thing, they are good conductor of heat and electricity or bad conductor of heat and electricity. So answer will be, they are good conductors of heat and electricity, right? So some of these elements are attracted towards a magnet. Very very important question can be asked, that out of alkali metals, alkaline earth metals, transition metals, which one of the following elements are attracted towards the magnet? So my answer will be transition metals. So very very important, next one, most of these elements are used as a catalyst. Actually, catalyst is what? That is a substance that increases the rate of a chemical reaction. It increases the rate, means your chemical reaction will happen fast, right? So it increases the rate of a chemical reaction. So most of the elements are used as a catalyst. Like iron also. So next one is my, most of these elements exhibit variable valences. So variable oxidation states, different oxidation states, they will show your transition metals. Next, very very important thing we are going to discuss, we have inner transition metals. Now you must know what are inner transition metals actually. So they are placed. Yes, what are you asking? One second, actually these are some basic points, these should be clear. Only these we are going to discuss. So they are placed at the bottom of the periodic table, inner transition metals. Basic thing you must know, only basic, that they are placed at the bottom. I am not discussing detail, basics should be clear. Like here we have lanthanides, we have actinides, only this thing you must know. Lanthanide, actinides, these are inner transition metals, they are inner transition metals. And this is also important about lanthanide and actinides, that they are heavy metals with high melting and boiling point. Variable valences, variable oxidation state, this is important, right? They form the colored ions. This question can come, they form the colored ions. Lanthanide and actinides, they form the colored ions. Next, this is also important, what are metalloids or semi metals? So certain elements which show properties of both metals and non-metals, they are called as semi-metals, or these are also called as metalloids.